Turns out, machine learning and your heart. Your teenager just ran a mile in under 7 minutes. They're fit, lean, and by every conventional measure, they're basically a cardiovascular superhero. And yet, a new machine learning model just flagged them as high risk for a future heart attack. How is that possible? Well, it turns out that the way we've been predicting who's actually going to have heart problems and who isn't might be completely backwards. Here's the thing about cardiovascular disease. It doesn't usually announce itself. By the time someone has a heart attack, the damage has often been accumulating for decades, usually starting in adolescence. We know that bad cholesterol, high blood pressure, and obesity are risk factors. We know that being sedentary is bad for you. But for decades, we've been using these factors like a checklist, as if cardiovascular health were a simple equation. Bad habits equal bad outcomes. Good habits equal good outcomes. The problem is, the human body doesn't work like a checklist. It's more like a symphony, where what matters isn't just whether the violin is playing, it's how it's playing together with the cello, the drums, and the entire orchestra. And we've been looking at one instrument at a time. This is where this research gets interesting. A team of researchers spanning Chile, Costa Rica, Colombia, Ecuador, and Spain decided to approach the problem differently. They wanted to see if they could use machine learning, artificial intelligence trained to find patterns humans might miss, to predict cardiovascular risk more accurately than we currently do. The lead author is Raúl Yáñez-Sepúlveda from Universidad Andrés Bello in Chile, working with colleagues across multiple institutions who specialize in everything from kinesiology to computer science. This kind of cross-disciplinary collaboration is becoming increasingly common in health research because neither doctors nor engineers alone can solve problems this complex. The study was published in June 2026 in Clinical Obesity, which makes it brand new. This is cutting-edge work, and it's asking a question that matters. Can we predict heart disease better by letting AI spot the patterns? Here's what the researchers actually did. They gathered data from a large group of adolescents and young adults, people typically in their teens through early 20s. For each person, they measured 3 categories of information. First, they measured maximal oxygen consumption, which is basically how much oxygen your body can use when you're working as hard as you possibly can. This is the gold standard for cardiovascular fitness. Then they measured broader physical fitness, things like muscle strength, endurance, flexibility, all of that. Finally, they took anthropometric measurements, which is scientific speak for they measured your body. Things like body mass index, waist circumference, body composition. Then they took all of this information and fed it into machine learning algorithms. Think of it like this. Imagine you're trying to figure out which weather patterns predict a hurricane. You could look at temperature alone, or wind speed alone. But if you feed a computer the temperature, wind speed, humidity, barometric pressure, and ocean temperature all at once, let it churn through thousands of historical examples, it can start to recognize combinations that humans might never spot. That's what they did here with cardiovascular risk. So what did they find? This is where it gets wild. The machine learning models were significantly better at predicting cardiovascular risk than traditional risk assessment methods. But, and this is crucial, it wasn't because they discovered that fat people are at risk and thin people aren't, that we already knew. It was because the AI found more nuanced relationships. For example, you could have someone who looks metabolically healthy by standard measures, but whose actual fitness level suggests underlying cardiovascular strain. Or conversely, someone who appears to have risk factors, but whose oxygen consumption and fitness profile suggest their cardiovascular system is actually quite robust. The machine learning models picked up on these contradictions and patterns that don't make sense in isolation, but tell a real story when you look at them together. Think of it like credit scores. Your income alone doesn't predict whether you'll default on a loan. Your assets alone don't either. Your debt-to-income ratio doesn't either. But feed all of those into an algorithm, add spending history and payment behavior, and suddenly you can predict defaults pretty accurately. This is similar. The combinations matter more than the individual numbers. Now, the effect sizes here matter. This wasn't a case where the machine learning model went from 51% accuracy to 99% accuracy. This is real-world research, and it's incremental. But incremental improvement in predicting something as consequential as heart disease is actually huge at a population level. If you improve prediction accuracy by even 10% across a whole nation, you're talking about potentially identifying thousands of additional people at risk before something bad happens. And when it comes to cardiovascular disease, early identification matters tremendously because interventions, exercise, diet changes, sometimes medication, actually work. They work better the earlier you catch the problem. Here's what this means for how we actually think about health. If you're a teenager, this research suggests that you can't just check boxes. You can't look at your BMI, see that you're in the normal range, and assume you're fine. You also can't have someone else's number tell you the whole story about your health. Your specific combination of fitness, oxygen consumption, and body composition matters. It's like having a fingerprint for cardiovascular health. The practical implication: if you have access to cardiovascular screening, and this is a big if, because not everyone does, you want the kind that looks at multiple metrics, not just one. You want someone measuring your oxygen consumption, not just your weight. You want tests that see you as a system, not as a collection of independent problems. But let's be honest about limitations. This study was in adolescents and young adults, which is actually important, because cardiovascular disease doesn't kill people that age very often. The risk it's predicting is long-term risk, the risk of having a heart attack when they're 45 or 55. We'll need follow-up studies that actually wait 15 or 20 years to see if the people the algorithm flagged as high risk actually do have more heart problems. That's the gold standard of prediction research, and it takes decades. Also, machine learning models can sometimes find patterns that are real in one population but don't work in another. So you'd want to test this in different age groups, different ethnicities, different populations, before it becomes standard medical practice. We're not there yet. This fits into a much larger shift in medicine toward personalized, multi-factor risk assessment. We've moved beyond an era where we thought you could just measure one biomarker, cholesterol for instance, and predict health. We're moving into an era where we're looking at the whole person: genetics, behavior, fitness, body composition, and more. Machine learning is good at this. It's what AI actually excels at, finding patterns in high-dimensional data. So expect to see more studies like this. The next logical question is, once you've identified high-risk people, what interventions work best for each individual? The algorithms that predict risk are just the first step. The harder question is, what do you do about it? Turns out, scientists have been busy, and they're not done yet.